Welcome back to part 4 on sine and cosine the functions. We're going to look at the phase shift defined now. The graphs of functions y equals sine of x minus b and y equals cosine of x minus b are sine and cosine graphs shifted horizontally to the left or to the right by the absolute value of b. So how far b is shifted from the point 0, 0 along the horizontal axis. They are shifted to the right if b is less than 0. And they're shifted to the left if b is greater than 0. The number b is the phase shift. So if we were to look at the example here, y equals cosine of x minus pi over 4, we know that b is pi over 4, the phase shift. These are going to get a lot more complicated as we move through the transformations of trigonometric functions. And so I'm going to show you how you can mathematically keep track of where your phase or your period starts and ends based on the phase shift, and a lot of other things. We know that one period of sine or cosine is on the interval from 0 to 2 pi. And so I can take the stuff inside the function, x minus pi over 4, and set up an inequality where we have 0 on the left and 2 pi on the right. If we solve for the letter inside the inequality in the middle, we would have to add pi over 4 to all three pieces of our inequality. When I do that, I get pi over 4 is less than x is less than 2 pi plus pi over 4. And so it might be helpful to think of this as 8 pi over 4 plus 1 pi over 4. So that will give me a total of 9 pi over 4. And this tells me, these endpoints here tell me where my period of this cosine function starts and stops. If I say that over here on the right is 2 pi, somewhere toward the middle here is pi, and if I break this up into smaller halves, having pi and having pi to 2 pi, I'll have pi over 2. And 3 pi over 2. If I break it up even further, then I will be to the denominators that I have in my phase shift. So that's my next step, is to break this up into additional pieces. Pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4. Do you see how I counted the reduced fractions as part of my steps? That's exactly what you need to do to draw in how far your graph has been shifted. And so I can draw this little section here. B equals pi over 4, and that is my phase shift. And I'm happy to report that this works every single time, which is so nice. So now my middle is here at 5 pi over 4. So my pattern will repeat, and I know that cosine starts at 1 and its low point is -1. And so I can just fill in my values here for the high points, low points, and then the middles are going to be the x-intercepts. And I can draw my curve that looks something like this. Every instructor is different when it comes to these, but I would say as long as you can find your phase shift, your maxes and mins, and you can label 5 points on the graph, you're probably good for sketching a graph of the trigonometric function. We're now going to look at amplitude. For functions y equals a sine of x and y equals a cosine of x, the number a in absolute values, because we're talking about a distance, we're not necessarily concerned with positive or negative, is called the amplitude and is the largest value these functions attain. We can think of amplitude as their max and min height. So if we were given y equals 2 cosine of x, the amplitude is 2. And if we were given y equals 1/2 cosine of x, we look at this number and the absolute value of a, or the amplitude, is equal to 1/2. If we were to sketch that really quickly, the amplitude for the first sketch would be something like this, where your maxes are at 2 and your mins are at -2. If we were to sketch the 1/2, it would be a more flattened out version where the maximums for cosine would be at 1/2 and the minimums would be at -1/2. Since the sine and cosine functions have period 2 pi, the functions y equals sine of kx, the sine curve, and y equals cosine of kx, the cosine curve, where k is greater than 0, complete one period when kx is between 0 and 2 pi. In other words, we would divide both sides of the inequality by k. And you can see that if you divide both sides of your inequality by k, you will get the number of times 2 pi can be divided by k. So this 2 pi divided by k defines the period. And so here, let's take a look at the first example for periods. It's y equals cosine of 2x. Remember that the standard period for cosine, we can say cosine x's period, is on the interval from 0 to 2 pi. And if we say that, then we can write our inequality as 0 is less than or equal to 2x is less than or equal to 2 pi, and then we can solve for x. If we divide all three sides of the tripartite inequality by 2, we get the period from 0 to pi. So that means that a normal cosine period would be a 2 pi long period where you have a max at 0, a min at pi, and then a max again at 2 pi. And your curve will look something like this. But now it's saying that the period only exists from 0 to pi. So that means that my period has been shrunk horizontally. And so now the period only exists, the same shape exists, but on an interval that is half as long horizontally. So the same graph has to fit in half as long a space. And so now the x-intercepts will be at pi over 4, 3 pi over 4. The maximum will be at 0. The minimum will be at pi over 2. Equilibrium will be at 3 pi over 4. And the maximum again will occur at pi. So you can see how the period has been smushed horizontally so it exists in half as much space. Now in this example we have y equals cosine of 1/2. And again we're going to sketch 2 pi. And actually, since I know what's happening, I'm going to say this over here is 2 pi. We'll call this pi. 3 pi and 4 pi. Now again, the period for a standard cosine function, cosine of x, is just on the interval from 0 to 2 pi. So if I want to find out what the period is for cosine of 1/2 x, that's saying that I take 1/2 x and I set up my inequalities for a standard period and then solve for x. So I'm going to multiply everything by 2, all 3 parts. And that's actually going to clear that fraction. So I'll have 0 is less than or equal to x is less than or equal to 4 pi, which is exactly what I had anticipated. What this is saying is you get half a period in a normal 0 to 2 pi period. So my maximum again is at 1. My minimum is at -1. My high points are on the far sides of the interval. My low point is in the middle of the interval from 0 to 4 pi. And my equilibriums are at the quarters. And so now I can sketch the graph of this cosine of 1/2 x.